Alright, this video is a review of functions. So let's start off with a definition. Alright, so a function is a correspondence between a set called the domain, which a lot of times you might think of them as domain meaning x values, and a second set called the range, which you would think of as y values most of the time, such that each member in the domain corresponds to exactly one value in the range. And you might see this said in a way that says, at most one instead of exactly one. The way we'll use it in our course, though, is typically exactly one. So another way you might see this said in layman's terms is that for every x value, there is at most one y value. So every x value corresponds to at most one y value. Let's just say y value there. Alright, so for every x value there's at most one y value. Let's take a look at an example here. So for each determine the domain and range, then state if the relation is a function or not. So taking a look at the first one, if I said f equals, so f is just the name of the relation, and curly braces signify we have a set. I'm going to give you a set that contains ordered pairs. So the first ordered pair will have 3, 9. The next ordered pair will have 4, 6. The next one will have 5, -2. And the last one I'll say 2, 6. Alright, so this is the set that contains these 4 ordered pairs. And basically we're just going to ask to identify the domain and range and then determine if this is a function or not. So for domain, and I'll use capital D for domain here. The domain is the set of all the x values in the relation. Well, we've got 3, 4, 5, and 2, right? Those first coordinates are always the x values. You don't have to list them in order, but I will here. 2, 3, 4, 5. A set does not need to be ordered, so it's okay to list them in any order you want. The range right? The range, remember, is the y values. The y values here are 9, 6, -2, and we have 6 again. We don't typically list it twice, right? So you want to list these 9, 6, -2. 6 again, we don't list it again though, right? So if it occurs more than once, you only list it once when you're listing these sets. And then we want to know, is it a function? Right, that was the last part of the question. Well, does every x only correspond to one y value? Well, 3 only goes with 9, right? There are no other 3 associations. 4 only goes with 6. 5 only goes with -2. And 2 only went with 6. So the answer here is yes, it is a function. And the reason it is because each x value corresponds with only one y value. In other words, right, each x value only goes to one y value in the association. You know, if 3 went with 9, but then you saw later on 3 also went with 7, that would be telling you that it was not a function, right? So the x values can never repeat. The y values can, right? The y values repeated, and that wasn't a problem. It's just that each x can only go to one y. Let's take a look at another one. So if I had, we'll call this relation G. So we'll have G equals the set that has the points 2, 7, 3, -6, 4, 8, -1, -6, and 3, 5. All right, so that set contains those ordered pairs, and we're going to be answering the same question. So if I said, you know, what is the domain? The domain is the set of all possible x values. So what do we have? Well, we've got 2, 3, 4, -1, and then I see 3, but I already used 3, so we don't write it again. So the domain here is 2, 3, 4, -1. The range, remember the range is the set of y values. So the y values, we have 7, -6, 8, -6 again, we don't write again, and then 5. So remember, domain, right, we're talking about the x values. The range, we're talking about the y values. And then, you know, that last part of the question, is it a function? Well, remember what we're asking, does every x value only correspond to one y value? Well, 2 goes with 7, and it doesn't go with anything else. 3 goes with -6, but then here the x value of 3 also goes with 5. So the answer here is no. And the reason is that x equals 3 corresponds to two different y values, right? 3 went with -6, but also associated with 5. So knowing that, right, the answer is no. So the x values cannot repeat. The y values can, right? It's not because this -6 repeated, right? 3 went with -6, -1 went with -6. That's not what limited it. If I didn't have this last point here, right, this would be a function because every x would be corresponding to only one y value. But because 3 corresponds with two different y values, it's not a function. So, just as a quick refresher here, right, if I talk about domain, this is the set of all, I'll call it input values When we say input values, most of the time, not always, these will be the x values. And when I talk about range, remember this is the set of all output values. And a lot of the time we talk about this, call these y values. They won't always be y. And when it's a function, what really happens is you put an x value into some function, which a lot of times we label it f. And what happens, you get out, we call it f of x, the function value evaluated at x. But f of x is really the same as saying y. So when you see a y value for a function, it's really the same as the function of that input, or f of x. So f of x and y are used interchangeably. So if I was taking a look here at an example that used this function notation f of x, if I said for f of x equals 3x plus 5, find, and we'll do a few of these. First one I'll say is f of 6. So instead of calling it f of x, we're calling this f of 6. What it really means is everywhere you saw an x in the original function here, you're replacing it with 6, right? So f of x was equal to 3x plus 5, so f of 6 should be equal to 3 times replacing x with 6 plus 5. And then you just simplify this like you normally would, following your order of operations. So I've got 3 times 6 is 18 plus 5. So 18 plus 5 is 23. So we have that f of 6 equals 23. Remember, when you do this, you really have an x and a y value, right? If I was looking at this as an ordered pair, the x value is 6. It's your input. The y value is 23. So you could also think of it as almost like a point on the graph. Typically we'll write it the way I have in the function notation, f of 6 equals 23. But it means the same thing as the x value of 6. The y value that we got out was 23. Let's take a look at another one for this, just to make sure we got it. If I said I had f of negative 2, well, that means substitute in negative 2 for every x value you see in the original function. So f of negative 2 is equal to 3 times negative 2, make sure you put the parentheses there, plus 5. 3 times negative 2 is negative 6, plus 5. Negative 6 plus 5, well, that's negative 1. So we have that f of negative 2 is equal to negative 1. If you're thinking of this in terms of an ordered pair, that's the same as saying the x value is negative 2. The y value you got out was negative 1. We could also substitute in variables for x, not just numbers. If I said, and I'll call this letter C here. If I said I had f of t, all that really means to do is put in t everywhere you saw an x in f of x. So this would be 3 times t now, replacing the x, plus 5. And since that doesn't simplify any further, that's it. That's your answer. F of t is equal to 3t plus 5, and that's it. And let's take a look at one more. If I said I had f of x plus h, what that's really telling you to do is take x plus h and sub it in everywhere you see an x in f of x. So this is equal to 3 times, we're replacing x now with x plus h. You need parentheses around this because, remember, 3 times this is what you're really doing. You say 3x. So it's 3 times whatever you're replacing with it. So 3 times x plus h, and then plus 5 on the end. Doesn't have any x's with it, so you don't change anything there. And then what you want to do is distribute this 3 through the parentheses. So you end up with, it's equal to 3x plus 3h plus 5. So f of x plus h is equal to the 3x plus 3h plus 5. So you know, if you have variables, you're substituting them in. You don't think of this as an ordered pair like we did in the first two examples with it. But really it's just, you know, a way of defining the function in terms of other variables. Right, let's take a look at another one here. If I was to look at this example, so if I said, given f of x equals x squared minus 9, we're going to find the following. The first one I'll say is f of negative 3. And you may want to pause the video as you're looking at this just to try it on your own and then compare your answers. So f of negative 3, it's equal to, remember you're subbing in negative 3 everywhere you saw an x and f of x. So it's negative 3, the quantity squared, minus 9. Negative 3, the quantity squared, remember that's in parentheses there because the whole negative gets squared, and negative times 9 makes it a positive, so 3 times 3 will give you 9, negative times 9 makes it a positive, so it's 9 minus 9, and 9 minus 9, well, it equals 0, so f of negative 3 equals 0, and you can just write it like that. You don't have to write an ordered pair like I did in those previous ones. That was just to show you that it was an ordered pair. Let's take a look at this one here. Call this one letter B. What if I said f of t plus 4? So trying that one out, remember, where you saw an x and f of x, you're going to replace it with t plus 4. So this would be equal to x squared. Now in this case, x gets replaced with t plus 4. So it's t plus 4 squared, and then the minus 9 will stay minus 9 because there are no x's with that term. And then we're going to expand this, right? So t plus 4 squared, what you can't do is you can't square each term individually. What you really need to do is think about what this means. T plus 4 squared means t plus 4 times t plus 4. So you're going to write it twice right next to each other. And then you're going to multiply those. In other words, we use FOIL, if you remember FOIL, multiplying, you know, first, the outer, the inner, and the last to simplify. So t times t is t squared. T times a positive 4 is plus 4t. 4 times t here is another plus 4t. And then the last 4 times 4 is a positive 16. And then this minus 9 still stays minus 9 at the end. And now we'll combine like terms. So when I combine like terms here, we've got, remember, like terms have the same powers on the variables. So same variables with the exact same exponents. So t squared just stays t squared. I have a 4t plus 14 is a plus 8t. Don't cancel those, right? Adding 4 plus 4 gives you a positive 8t. You have plus 16 minus 9. Those are like terms because they're both constants. 16 minus 9, that's going to be a positive 7. So you end up with t squared plus 8t plus 7. Now don't factor this. Don't do anything else with it. That is the final answer. Remember, you can't combine these because they're not like terms here. Remember, you have to have the same variables with the exact same exponents. You can't combine those. And then the other thing to point out is I couldn't just square the t and square the 4 here. If you have addition or subtraction inside the parentheses, you do have to write it next to each other and distribute through to multiply out. Let's take a look at one more for this one. So if I had f of x plus h. Well, again, this means you're replacing x in the original function with x plus h everywhere you see it. So x squared is really x plus h quantity squared. Make sure you put parentheses around that. And then minus 9. And we will again expand what we have here. So you really write x plus h squared. Remember, it has to be x plus h times x plus h, and then the minus 9 still at the end is minus 9. We will distribute through here, in other words, we'll FOIL, so we get x times x gives us x squared. Here the outer x times h is plus xh, the inner h times x will be plus, h times x is the same as x times h, so I'll say plus xh, and then h times h gives you plus h squared, and then minus 9. And again, we want to combine like terms. So if I combine like terms here, I end up with X squared stays x squared. We have xh plus xh, so that's plus 2xh. Remember, you're adding the coefficients. There's really one of them here plus one of them here, gives you two of them total. Make sure if you wrote this as hx and this one is xh, you know those mean the same thing. So you have 2xh and then plus h squared minus 9. And now, since these don't combine any further, in other words, there are no other like terms, that is what f of x plus h is. And we're going to look at just a couple more just to make sure we got this down. Again, you might want to try this on your own first before we go through it together. So you might want to pause the video. But if I said, for example, given f of x equals 2x squared plus 4x minus 1, and we're going to find the following. So the first one we'll look at, I'll say, is f of negative 3. So for f of negative 3, remember that means that where you saw an x and f of x, you're replacing it with negative 3. So you'd have 2 times negative 3 squared plus 4 times negative 3. Make sure you put parentheses because you're multiplying that. And then minus 1. And then we simplify this. So remember, when you simplify, you're following your order of operations. So you can't just multiply the 2 times negative 3 here. You have to do the negative 3 squared first because that's the exponents. So you have 2 times negative 3 squared, so it's 2 times positive 9. Positive 4 times negative 3 makes this minus 12. Minus 1. And then 2 times 9, that'll be 18 minus 12 minus 1. 18 minus 12, that gives us 6 minus 1, this equals 5. So f of negative 3 is equal to 5. Let's try another one. If I said we had f of 4t. Now when I say f of 4t, remember that means everywhere you saw an x and f of x, you're replacing it with 4t. So this leaves us with 2 times 4t squared, replacing that first x, plus 4 times in parentheses, replacing that x with 4t, so times 4t, and then minus 1. Now, again, we're going to follow our order of operations here, so you can't multiply the 2 into here. You have to do the 4t squared first. Now, since there isn't any addition or subtraction in here, you're allowed to square the 4 and square the t individually. So this equals 2 times 4 squared, give you 16. T squared gives you t squared. So it's 2 times 16t squared. Plus here, there's no exponent on the outside, so I can multiply these together right away. 4 times 4t is 16t minus 1. And then simplifying this, 2 times 16t squared, that gives you 32t squared plus 16t minus 1. And none of those are like terms, so you can't combine it any further. And we'll look at one more example for this function. If I had f of x plus h. Remember what that means. It means you're substituting in x plus h everywhere you saw an x in f of x. This is equal to 2 times x plus h quantity squared plus 4 times x plus h minus 1. When you do this, right, you have 2 times x plus h quantity squared. You can't bring the 2 through. You have that squared on the outside, so you have to simplify it by writing it x plus h times x plus h. Remember, that means write it twice. Plus 4 times x plus h. Here you can distribute the 4 in right away because of the fact there's no exponent on the outside. So 4 times x will give you 4x. 4 times a positive h makes that plus 4h. And then minus 1 at the end here. To multiply this together, you could do it in any order you wanted. I typically would multiply the two things that I was foiling first and then distribute the 2 through after that. If you remember from earlier, 2 times, well, x plus h times x plus h, That's what we did right here. It ends up being x squared plus 2xh plus h squared. It really comes from those middle terms of FOIL adding together, right? So it's 2 times x gives you x squared. From the outer, you would get x times h, which gives you xh. From the inner, you also get xh, so that's plus 2xh. And then from the last, you get plus h squared. Close those parentheses off because the 2 is being multiplied just to that term. And then plus 4x plus 4h minus 1 will just come through. And then we'll distribute into this. So we end up with, this is 2x squared. 2 times 2xh makes that plus 4xh. 2 times h squared makes this plus 2h squared plus 4x plus 4h minus 1. And are any of these like terms? And the answer here in this case is no. So you're going to leave it. Right? Remember, to be like terms, they have to have the exact same variables with the exact same exponents on those variables. And let's take a look at this here. So if I said given f of x equals x minus x squared, right? So x minus x squared, we're going to find the following. So the first one we'll look at is f of x plus h. You might want to pause it and try it on your own. So when you look at this, remember f of x plus h means that we saw an x and f of x, you're replacing with x plus h. So the first x gets replaced with x plus h, so that's me just replacing that part with x plus h, minus x squared. Remember, the x gets replaced with x plus h, so it's minus x plus h. That whole quantity is getting squared. And from there, x plus h will just stay x plus h, minus, now when you have x plus h quantity squared, remember what that really means, right? We talked about it earlier. We've done it several times now. It really means to do x plus h times x plus h, and we know what that comes out to. Now this negative in front means you need parentheses around the whole thing because the negative is going to need to get distributed through. It belongs to the whole term after it. So it's going to be minus x squared plus 2xh plus h squared. This is me remembering when I FOIL this what it comes out to from earlier. It's used often enough where you probably should know that as well, but feel free to FOIL this out and get to this point. Once I have this negative sign needs to be distributed through here. That's why I kept those parentheses. Without it, it changes the signs that you have. So this ends up being x plus h, and then we're distributing a negative, because really it's like a negative 1 in front. So it's really like negative 1 times a positive x squared makes this negative x squared. Negative 1 times a positive 2xh makes it negative 2xh. And negative 1 times h squared makes it negative h squared. Now, are any of these like terms? Well, the answer is no, because none of the remember, to be like terms, they have to be the same variables with the same exact exponents. You have the same variables showing up, but they don't have the exact same exponents on them, so you can't combine them. And that would be what f of x plus h is. A little bit later in the course, when we go to talk about finding derivatives, which is part of calculus, we'll talk about this next piece that we call the difference quotient. But for now, let's just say if I ask you to find f of x plus h minus f of x all over h, this is kind of a specific thing that we're looking at here. F of x plus h, well, that's just asking us to do the part we did in part A. So we know what that is. That's this right here. Right? So if I went to write out what that is, that would be equal to x plus h minus x squared minus 2xh minus h squared. I already found that, so I don't have to do any work for it because I did the work up here. If I didn't ask you to do this first thing you would do is find that and then replace it in that first part of the expression. Then we have minus. Now we want to subtract off f of x. So what's f of x? F of x, that's the original function, right? That's the one that was given to us. So the original function is this x minus x squared. So I'm replacing f of x here with x minus x squared, but you need parentheses because that minus sign is going to belong to all of it. So minus x squared, that's me replacing f of x with the original function, right? The function that we had up here. And then this whole thing should be over h. Now we want to simplify this. Now to simplify, you can't just start canceling h out from the denominator with things above it. You only can cancel things out that are factored, so things are being multiplied when you're trying to cancel things with the denominator. So first I'm going to simplify. So to simplify this, I'm going to distribute the -1 from here through. So we end up with just keeping this x plus h minus x squared minus 2xh minus h squared. A -1 getting distributed through. A -1 times a positive x makes it negative x. A -1 times a negative x squared makes it positive x squared, and it's all over h. And now I will combine like terms. And combining like terms up here, let's take a look at what happens. You've got this x minus x, so those are going to cancel. You have a positive h. I think we keep that, right? There's nothing that cancels with it. We got a negative x squared and a positive x squared, so those will cancel out, right? Because a -1 plus 1 cancels to a 0. We have negative 2xh, which doesn't combine with anything. We got minus h squared, which doesn't combine with anything. This is all over h. And now what we'll do is, like I said, you can't just start canceling h's out. The way that you might be able to cancel those, if you can factor something out of the numerator that might also cancel with the denominator, then you can. So from the numerator, I'm going to factor out a GCF. H minus 2xh minus h squared is the greatest common factor of h, so I'm just going to factor h to the front. And remember, when you factor out, you're really dividing each term by whatever you factored out and writing what's left over. So if I take h and I factor out h divided by h is 1. Make sure you have that there. Don't cancel it to a 0. 2xh factoring out the h means that you're going to take it out of there. 2xh divided by h is just minus 2x. Right, that's how you factor it out. And then minus h squared, you factor out an h, so you're left with minus h. And remember, this whole thing is still over h. And now that we're here, you're allowed to cancel these h's. Typically, the reason is that since h doesn't equal 0 is what we're going to really say. Because if you had 0 over 0, that's indeterminate form. So we're allowed to cancel these as long as h doesn't equal 0. So we'll cancel these h's out now. And the reason you're allowed to cancel is because you have things that are being multiplied together. So if they're factors, you're allowed to cancel factors through division, but you can't cancel from individual terms. So since we had things that are being multiplied, we're allowed to cancel them when we're dividing like that. And we're left with 1 minus 2x minus h. And we say provided that h doesn't equal 0. So that would be equal to the difference quotient, right? The f of x plus h minus f of x all over h is equal to this 1 minus 2x minus h as long as h doesn't equal 0. One of the last things we'll talk about here in terms of functions, we'll talk about the vertical line test. The vertical line test really gives you a way of determining if a graph is a function or not. So if I wrote the vertical line test, I'll write it formally in words. It's actually easier to do than what the words even say. The vertical line test tells us a graph represents a function if every vertical line drawn through it intersects the graph at most once. So vertical lines, make sure you know what I mean. Vertical lines are lines that are straight up and down. For every line that you draw straight up and down through the graph, it can only hit the graph one time. If that's true, then it is a function. If it hits more than once, then it is not a function. So let's take a look at an example here. I'll just say determine if each graph is a function. And I'm just going to draw you a graph and we can just take a look. So, you know, here's an x and y axis. So here's x, here's y. And I'll draw a graph that, you know, looks like this. So is that graph a function based on the vertical line test? Well, all you got to do is look at it and say, okay, if I draw a vertical line through this, how many times does it hit? Well, it only hits once, right? Anywhere I draw it, it only hits once, right? If I draw it here, it only hits once. So since every vertical line I would draw through this only touches the graph once, or at most once, the answer is yes, it passes the vertical line test. So yes, this is a function, right? VLT, vertical line test for short. Let's take a look at another one. Call this one letter B. If I was to draw an x and y axis here, here's x, here's y, and I'll draw this graph that looks like this. So like a sideways parabola type shape. Well, the answer here by the vertical line test is draw a vertical line. That one hits twice, so the answer is no, it's not a function, right? Right, it fails the vertical line test. In other words, there is a vertical line that I can draw that touches the graph more than once. Now, there are spots sometimes where you could hit just once, right? Like if I did it right here, right, that vertical line would only hit one time. But as long as there's at least one line where it hits more than once, then it fails the vertical line test, so the answer would be no, not a function. And we'll take a look at one more. And this one here. So here's x, here's y. And maybe I'll draw it like this. So is that a function? Well, the answer here, vertical line test, will be no, because there are places on this graph where if I draw a vertical line, it'll touch more than once, so it fails the vertical line test. Right, if I had just drawn things over here to the right, it would only hit one time. But every vertical line can only hit at most once. So as soon as there's one spot where a vertical line hits more than once, or touches the graph more than once, then it doesn't pass the vertical line test and it's not a function. And that's because the x value that would be associated here would have two y values. That's really the way you should be thinking about that. That's why the vertical line test works the way it does. What it's really doing is ensuring that the x value only has one y value that goes with it. So hopefully this video on functions was helpful. If you want a little more information, the next video we'll be looking at has to do with piecewise functions, which take on different graphs for different parts of the domain. So hopefully this video was helpful.